that has to deal with density, and I'll explain a little bit about density in a couple minutes. But basically what you're going to do first, if you look at where it says objectives, I'll read them to you. It says the first objective is to demonstrate the density of an object will float, suspend, or sink in water, to know the density of water, and to use the formula, which is density equals mass divided by volume. You're going to be using these materials: a triple beam balance, 3 empty film containers, which we used before in class, a small plastic tub filled with water, which we're actually using these aluminum tubs, a small object of various masses, so you will have marbles, pennies, paper clips, and a large graduated cylinder. We're also going to use a beaker for this lab. Okay, so look at the procedure. There's part 1 and part 2. You guys look at your paper. Part 1 and part 2. The first thing you're going to do for part 1 is you're going to get a beaker and fill it about halfway to 3/4 of the way with water. Okay? Then you're going to get your canisters. You're going to have 3 of them. And you're going to fill them with various objects, either marbles, pennies, or paper clips, so that 1 canister will float in the water, 1 canister will suspend in the water, and 1 will sink. So for instance, to make it suspend, I might want to put 2 marbles. Let's see if this makes it suspend. So that's not enough. I'll put a couple pennies in there too.
That's not really float.
You know what?
I think it's just 4 inches in the little thing. Sorry, aluminum.
You have to make sure your lids are closed too, because they might take in water. So that one's floating. The suspending one will have the lid's going to be out of the water and the bottom will be in the water.
So it's like somebody swimming.
And then the third one is going to sink. So you're going to put a lot of stuff inside of it to make it, weight it down. Okay, so I put pennies and marbles in there. So if I put this in, it should sink.
Okay.
And it does.
That's cool.
Okay? So now we're still in procedure part 1. Look at step number 5. Step number 5 says have your teacher check your canisters before you proceed to the next part. So you need to show us that 1 canister sinks, 1 suspends, and 1 floats on the top. Once that is finished, you're going to move on to procedure part 2. So everybody follow along with procedure part 2 on their paper. Procedure part 2 says, once you have completed part 1, use the equipment provided to find the mass and the volume of each canister. So we're going to use the triple beam balance to find the mass. Remember to calibrate it to 0. And then you'll take each of your containers, and please make sure that they're dry. You'll take each of your containers, you'll put them on the triple beam balance, and you'll figure out the mass, just like we did a couple days ago. You'll write the mass down on the worksheet. So every container will have a different mass. When you're done doing that, you'll have to find the volume of each container. Now, with volume, we're going to use water displacement. And this is a method of water displacement we haven't done before. You're going to get your beaker. So everybody look at me while I'm doing this. You're going to get your beaker. You're going to fill your beaker as close to the top as you can. You might need to top it off a little bit with some extra water. Now, we only have to do this with one of the canisters. You're going to use the canister that's the heaviest canister, the one that has the most mass. We're going to carefully place it inside. And you see that that canister displaced some of the water. Okay? We're going to take this beaker off. And all the water that spilled out was what was displaced. So we're going to pour that into our graduated cylinder. And you're going to read your graduated cylinder. Remember to read the bottom of the meniscus. So this is about 39 milliliters, which means that this canister takes up 39 milliliters. And all of the canisters are the same volume. So on your worksheet, all 3 boxes will have the same volume. Then we have to figure out density. Who sees what the formula for density is on their paper? Travis, yeah. Good. So density is going to be mass divided by volume. So you're going to take the mass, put it in your calculator, divide by volume. That'll give you the density. When you finish that, you'll clean up, and then we'll work on the conclusion tomorrow.